electric flux. This topic is the key. These two formulas would be the key for you to understand Gauss theorem. Gauss theorem is the most terrifying thing. If you understand it, it's okay. You can proceed on to the applications. If you don't get it, it could take you an eternity, and you might stick on it. So just don't worry. It's always Gauss theorem is tougher as compared to other theorems, but by learning these two formulas, and just do remember that there is nothing so tough in the syllabus. Uh, but Gauss theorem can be tough, and also chapter 3 current electricity has Kirchhoff's law, Kirchhoff's second law. Yes, it can be tough to many. If you reach there, if you just uh, go to that topic, because it's gonna be the last topic of that chapter in NCRT. Let's see where we will keep it in our one shot. Anyway, for now, flux is the key we have unlocked to go to Gauss theorem. But we just can't go down simply to Gauss theorem without understanding Coulomb's law. Coulomb's law is a basic law, and you need to understand what epsilon naught means from Coulomb's law. Okay. Uh, Here is our plan. Here was our plan, previous plan, and we have done electric force, field, and flux. Now Coulomb's law, then the terrifying Gauss theorem, and applications of Gauss theorem. And dipoles will be dealt somewhere. I would tell you, but before dipoles, before even starting dipoles, we will start chapter 2. Okay, so don't worry, in between some chapter 2 to chapter 3 we would deal with dipoles. There will be chapters provided, don't worry, timestamps would be there. Then by using it you can directly reach to dipoles. And another topic which is, I told you in mid, electric field lines. This topic is there, but it's simple. It's just a graphical representation of electric field, and although this topic is simple, definition is easy. Let's do it beforehand, but we will do it after doing Coulomb's law. We will do electric field lines and its properties, but first of all, let's do Coulomb's law because it's a basic topic. Most of the people start with Coulomb's law. It's so basic that most of the people just waste their complete year at Coulomb's law. Most of the year, people solve J means problems, J advanced problems. What type of heavy problems you solve on Coulomb's law, and even on electric field, and after that nothing happens. They don't have any clue of electric flux, Gauss theorem, dipoles. Oh, what? These are some not in our syllabus, but actually you are. If you have reached, if you have already learned Coulomb's law, just don't worry. We won't spend too much of time dealing with it, but it's important to go to our further exploration of the syllabus of the unit of electrodynamics. This is the Coulomb's law right here in front of you. But wait, even before starting Coulomb's law, we had previously done electric flux, and it was an important topic. As I already told you, it would be the base, but uh, I think so. I do think so that your NCRT must have some questions on electric flux. Before doing the Coulomb's law, let's do numericals on electric flux. Okay, just here's the formula: E dA cos theta, and here's the numerical. Now, let's try to understand it. The electric field components in figure this are Ex, Ey, Z is equal to 0. Oh, in which alpha. And I personally, I never ever solved. I myself, I am a student. I never ever solved NCRT examples before. So this is even my first time of attempting them. Okay, so it's just a honest, hands-on review that you would see the electric field components in this figure, whatever figure, are Ex, Ey, Ez. Okay, X, A, alpha is equal to, hey, wait. Electric field, what? Newton per coulomb meter inverse? Would it even correspond to electric field? Electric field have unit of Newton per coulomb. Okay, this one. Okay, NCRT. Anyone could misunderstand this. It can be written like this. It can also be written like this. This should have used brackets so that it becomes clear that this is not a multiplication of n. This one is wrong dimensionally. Okay. So this 0. Okay. Equate the flux through the cube and the charge within the cube. Wait. Hey, we don't know the charge within the cube. How can we even know it? Oh, Gauss theorem. Since the Gauss theorem is already explained, we can know the charge within the cube using Gauss theorem, but at least we can find the flux with our available knowledge. So the electric field is given. Let me write it down clearly. Electric field is given just in some format in which we are not used to. Electric field x component is alpha distance under root. You can write it this way also. 0, and for electric field in z also 0. So finally we can write electric field vector is alpha under root x I cap plus 0 j cap plus 0 k cap, which simplifies to this. Just avoid writing this since it's 0. Now just put alpha is equal to 800 Newton Coulomb meter. So we could get, I would avoid writing units. Newton per Coulomb. The final answer would be Newton per Coulomb, because don't worry, the final answer would be Newton per Coulomb. This is in meter, under root meter when being multiplied, they would cancel in final Newton per Coulomb. I kept. Okay, so this is our electric field, and find the flux through the cube. Assume that A, okay, side of the cube is A. Children could easily confuse between alpha and A. Just be careful, very careful with it. Alpha looks different than A. Both are different symbols. Even keyboard understands there are different symbols in computer to denote alpha and A. Just be careful in your examinations. Alpha is a more of sharp italic, and there is a little bit of more bulging out here, sharp. If you can see, let me zoom it. Yeah, this one is alpha. There is a little bit of outward styling, okay, and A doesn't have this. A stops here just, but alpha continues to move. This line continues to move. So just do remember the distinction between these two letters. So A, the side of the cube is what? 0.1 meter. Side of the cube is 0.1 meter, but I don't want it. I want to know flux, and flux is area vector. It requires area. Okay. And cos theta. Sorry, just remove the sign. I will put the theta and let me know the theta from here. Where is electric field? Electric field is moving in this direction. Cube is placed in this direction. How can I get theta? Theta. Oh, I think so. This one is area vector. Okay. So electric field is moving this. Area vector is this. So electric flux through the cube. Hey, I need to find flux through this surface. Flux is for surfaces, not for whole volume. So for this surface I need to find, for this surface also I need to find, for this also, for this also. Okay, now we go for this surface. Flux, this is area vector and this is electric field, completely opposite. So it's 180 degree, and theta is 180 degree. First of all, just let's find out area. Area is equal to A into A square, or, and it's 0.1 square. It's 10 to the power minus 1 square. Finally it's 10 to the power minus 9 minus 2 meters square. So we could, hey, we just don't need to integrate it because we don't get in variable functions. So we could just simply write, instead of integrating, cos theta. Okay, now let's find out for each area. This surface, this surface, this surface, this surface, this completely 180 degree. I would call this surface is 1, this one is 2, this one is 3, 4, and what more? And this backward surface 5, and front surface, it would get messy, too messy. There is a 6 surface also. This one is that back one, and this one is front one. So the flux should be Net flux should be flux of first surface, second surface, third surface, fourth surface, fifth surface, and sixth surface. Now just see first surface. For first surface, EA cos 180 degree. Okay, 180 degree. It's equal to minus 1 minus EA. Okay, wait. So here, since again 180 degree, since area vector is pointing in this direction, minus x minus I cap, this one is in I cap. So finally 180 degree, 180 cos 180 degree is minus 1. Need to be remembered. So it would give you minus EA. Let's do for flux 2, for surface 2. For surface 2, area vector is pointing in this direction, and electric field is also pointing in this direction. So theta is equal to 0. Here EA cos 0 degree. And I do remember that EA, I think so, it's a company name. Somewhere I have seen it. Anyway, first let's do it. EA cos 0 is 1, cos 0 degree is 1 plus 1, and cos 180 degrees minus 1. Okay, so this gets plus EA. Now for surface 3, 4, 5 and 6, it will get 0. Let's see how. Area vector is pointing downwards for third surface, and electric field is pointing this wards in right direction. Now the angle would be 90 degree. Angle would be 90 degree. Okay, cos 90 is 0. So finally we would get 0 for it. 0. For fourth surface, again electric field in this direction, area vector in this also would get 0 because it's a cos function. We are doing dot product, and once you get perpendicular, 0. Even in maths also it's something. Even in maths also, if you have learned, if A vector is perpendicular to B vector, then it implies that A vector dot product of A vector and B vector is 0. Not only this, it's also other way around. If this is dot product is 0, then it gives that A vector is perpendicular to B vector. So now flux of 5, fifth surface. The fifth surface is this inward part, that backward surface, and its area vector is pointing in negative z direction, negative k cap, and electric field is pointing in I cap. This and this, they are again perpendicular, so even this gets 0. Now this surface, its area vector is pointing in this direction, positive k cap, and this one is positive, electric field is in positive I cap, again perpendicular, so area vector is 0. So finally, just don't need to add 0, just rewrite. Okay, let's write it 0 0 0 0, 4 zeros, total 6 surfaces. So even this get cancelled, and we get final net flux as 0. Just don't write unit for 0 values. And yes, here is the net flux 0. Let's see if we got it right. Net flux through the cube. Hey, it looks something. Am I right? Answer actually gave an answer. Not possible. How is it even possible? Huh? Oh no. Wait. Hmm. Hey. Just wait for a while. And anyway, hmm, since electric field is function of distance, and these two surfaces, this one and this one, first and second, they are separated at a distance. So this EA, E for first is not equal to E for second. So they don't get cancelled actually. So it's something which goes like minus E for 1 plus E for 2A. Now E for 1, electric field for 1. For first surface, uh, how can I know this x distance? There's nowhere mentioned about this x distance. The distance of the surface from origin, not mentioned anywhere. How can I put this? Anyway, let's assume it as x. Let's assume it as x minus alpha root x, and this one is area. So we will put 10 power minus 2, and for this E2. E2 is something x plus a, x plus a. So it would get us x plus a in under root, whole under root alpha into 10 to the power minus 2. I don't know how it would even solve. They should have told that the cube is kept at the origin. Let's see what the NCERT is done. I think so that they considered wrong. Just it's stupid. They considered this existence as equal to a, but it's nowhere mentioned. I don't think so that this distance is must be a. This can be a, but this how can this be a? Wait, it should be x. They should have specified. Just question is absolute error. We can't solve it further. We could maximum get to the point if we put alpha is equal to minus 800 x in just this divide 0 cancel, and again 0 would cancel. We could at max get to the point of saying it like that minus 8 under root x plus 8 under root x plus 8. This could be the maximum which we could solve. This is what answer is. Answer should be, but it's not. I won't be awarded any credits for this because NCRT considers this distance as A. So let's assume assume the cube is placed at x distance. Assume the cube, not no. Assume the surface 1 of cube placed at x distance from origin. Placed at a distance from origin. So phi net would get equal to a. I don't think so that let's try. Now it would get at least solvable. Just take out common. 8 root a. 8 root a goes away and we get root 2 minus 1. Okay, now root a 8 a is equal to 0.1 meter. Yes. Okay, he wait, was it wrong? Never called you get it wrong. No, correct. So just put root a is equal to 0.1 and this is root 2 is equal to 1.414. Yeah, I think so. So 1.414 minus 1, 8. Okay. Yes, and this turns 414. Finally, something like 414 under root 10. Is it so? Anyway, let's solve it because NCRT doesn't give any steps. If the answer would match, then it would be right. And for root 10, let me check the value. Root 10, 3.16. 3.16. It's closely. No. We can cut it somewhere. Let's just divide it. 3.312 divided by 3.16. 1.05. Flux has unit. So let's see, does it matches? Yeah, it does. It does matches, but the question was faulty in itself. Where did they even told? Where did they even tell that the cube is placed at this distance? They never told. You just read it yourself. There's nowhere told. Even in the diagram also, it's nowhere told. Hey, but it can be. Hey, just. I think so that this A is telling you that it's here. Maybe this A, and this A. But if this A is in Z direction, this A is in this plane, so this A must be in this plane. Why would NCRT again put it in this plane? Both two terms in same plane, and this one in Z axis and Z axis and X axis plane. Why? Why this in K cap? Why this in I cap? And this should then be in J cap. But they can use this A to justify. So just please be careful with this. Bloody shit. And for charge, find the charge within the cube. Okay, charge within the cube can be found using Gauss theorem. The charge within the cube can be found using Gauss theorem. And let me take some efforts to explain a Gauss theorem for the sake of this question. So here is Gauss theorem. Gauss theorem can be used according to Gauss theorem. The net flux is equal to total charge q net divided by epsilon naught. Now what is epsilon naught you will understand in Coulomb's law, but just remember epsilon naught is having a value of 8.854 into 10 to the power minus 12 minus 12 Newton meter square by Coulomb square. Just put the values in this formula, and by Gauss theorem you can find this charge. This one is constant, we know this value already, and just we need to find the charge. Q net is equal to epsilon naught times phi. So just let's do it. Put phi is equal to 1.05 as we found, and epsilon is equal to 8.854 into 10 to the power minus 12, and q is epsilon phi. So we need to multiply this small looking number, two decimal, three significant figures. Okay, let's just remove this 4. Hey, sorry. 2, 4, 4. Okay, 9.2925 into 10 to the power minus 12 coulombs. Let's see, is it 9.29 and it's showing 9.27. Anyways, this much of errors are okay. It doesn't usually matter at all. Just don't worry for these types of errors. These are not errors, these are just approximations. uh, okay, it's just okay. I think so that NCRT has gone wrong at it, because let's use the calculator. 10.05 into 8.85. You can see my calculation is exactly right, and even if we add 4 also, then it would get even larger. Okay, so NCRT is wrong here, because it also multiplies by 1.05 into 8.854. 8.854, yes, 8.854 into 10 to the power minus 12. This one is wrong. And even if some mistakes occur at this minute level, is just a very small marginal error in the second decimal point, and second decimal point errors are not too big. Just you won't be deducted any marks for such small negligible errors. So here is the answer. You could even approximate it. It's 2.29 into 10 to the power minus 12. And yes, I missed one concept of microcoulomb and nanocoulomb. Micro is a prefix, it's equal to 10 to the power minus 6, and nano for 10 to the power 9. Minus 9, sorry. Okay, so we can write this in terms of nanocoulomb. Just divide it by there is 10 to the power minus 9 nanocoulomb, 10 to the power 9 coulomb in 1 nanocoulomb of charge. ओके, एंड दिस वन इज कूलम, ये ऊपर जाएगा, और फाइनली ये तो कट जाएगा क्योंकि माइनस माइनस कट जाएगा, माइनस 10. 9.29 into 10 to the power minus 10 nano coulomb. ओके, ऐसे लिख सकते हो आप चार्ज को. सो विथ this numerical is done, and let's see if we can even do this big question right there. So big. Electric field is uniform in the positive x direction for positive x. Okay, and uniform the same magnitude in negative n. Electric field is uniform in the positive x direction for positive x, and uniform with the same magnitude but in negative x. Okay, I think so that some uh, figure is there, and for the part in this positive x, electric field is in this direction, and for this part electric field is in this direction. It is given that, okay, for x is okay, same thing, just we got the magnitude as well. A right circular cylinder of length 20 centimeter and radius 5 centimeter has its center at the origin. Okay, this we are talking of a circular cylinder placed what the, and its axis along axis, yes, it's placed in uh, sleeping position, yes, in sleeping position the cylinder is placed. This is the cylinder. Sorry for not I was I thought that it was visible to you. Anyway, the cylinder is kept in sleeping position. How we get it? The axis of cylinder is along x-axis. Where the axis? This is the axis. Okay, so that one face is at x is equal to plus 10 centimeter and the other is at x is equal to minus 10 centimeter. So this is the basic information which tells us total length is 20. One of the faces at plus 10, one of the faces at minus 10. Total length is 20. So it tells us that it's placed at half. Half of the cylinder is here, half of the cylinder is here. And the other is what is the net outward flux through each flat face? Each flat face. So we just don't need to add both of them. We just need to find for both the faces. What is the flux through the side of the cylinder? And what is the net outward flux to the cylinder? What is the So it's a hypothetical question. Nothing of this sort happens in actual reality. That at z axis, this different electric fields are being applied in different directions. Anyway, well, actually, it's easy. It's easy. I'm not have yet seen the solution, but I think so. It's easy. We just know. Let's do it after a short break. I need a short break. Don't worry, I will march. Just try it yourself.